By the mid-1950s, the U.S. was conducting reconnaissance flights over the Soviet Union using U-2 aircraft flying at high altitudes. However, Soviet defenses were advancing enough to render the aircraft vulnerable, and the overflights ended in 1960 after the Soviets shot down a U-2. Prior to this, research into the feasibility of reconnaissance from space was being researched by the Air Force. Around the same time, the CIA began a program called Corona. There were 13 failures before a successful attempt in August of 1960 to return images from space. Those early spy satellites were limited by the technology of the period, often returning poor quality images, and they could not rapidly respond to new targeting requirements. Air Force studies of the feasibility of military satellites and space stations began in January of 1957. A technical paper was published that included a discussion of a crewed space station in July of 1957. Research was accelerated in the wake of the launch of Sputnik by the Soviets in October of 1957. More focused studies of a crewed space station started in September of 1959, and Air Force studies continued through 1959. In February of 1960, the Air Force began accepting proposals from contractors for a manned test space station. In August of 1960, 5 companies were selected: General Electric, Lockheed Aircraft, Martin, McDonnell Aircraft, and General Dynamics. The contractors presented their design proposals for the MTSS to the Air Force in January of 1961. The MTSS project was initiated in July of that year. The project was seen as having great potential. However, lack of knowledge of operations and astronaut performance in zero-G made it difficult to proceed, and plans were made to gain information from NASA's Gemini project. By May of 1962, the basic design was finalized. The spacecraft would consist of a lab module with an attached Gemini capsule and would be launched atop a Gemini 3 launch vehicle. It was originally planned for a crew of 4 spending 30 days in space and was planned to be operational by mid-1966. In August of 1962, manned orbiting lab studies were approved. MOL was a joint classified project of the U.S. Air Force and the National Reconnaissance Office, with the goal of developing a crewed spacecraft for low Earth orbit operations. A reconnaissance mission was proposed, with the ability of astronauts on board to be able to select targets for imaging was emphasized. At the time the program started, space flights had successfully flown, but those missions were relatively short, hours at the most, while missions lasting up to 60 days were envisioned for MOL. Needed were advances in life support and spacecraft reliability, as well as advances in acquiring the required imagery in the short period of time over a target from orbit. During this period, much effort was made to coordinate with NASA to avoid duplication of human spaceflight operations, and there was cooperation between the Air Force, the National Reconnaissance Office, and NASA. It was intended to be a secret black project, although the project wasn't entirely possible to hide from the public, and 20 civilian experiments were added to the program. It was to use the Gemini B spacecraft and the Titan III booster, with 6 flights planned, with the first flight being uncrewed, followed by 5 crewed missions, with the first flight planned for 1966. 2 astronauts would launch and return to Earth aboard the Gemini B spacecraft, which was a modified version of NASA's Gemini spacecraft. Gemini B was similar to the NASA Gemini, although it was modified for use with MOL. The modifications were a rear hatch in the heat shield for access to the MOL module, a larger heat shield for re-entry from polar orbit, and a modified cockpit layout. The Gemini B hatch would be connected to a tunnel leading into the lab module, which would be 19 feet long and 10 feet in diameter. The main payload was a telescope imaging system for reconnaissance. NRO development of the imaging system was derived from previous imaging systems developed for earlier reconnaissance satellites. In early 1964, a contract was awarded to Eastman Kodak to study the ability of astronauts to select imaging targets. And in March of that year, the project was given the code name Dorian by the NRO and given the designation KH-10 in line with the series of keyhole reconnaissance satellites. It consisted of a camera system developed by Eastman Kodak and was more advanced than that of the earlier reconnaissance satellites with improved resolution. It could be manually controlled by the crew via a telescope to see if a target was clear for imaging. Having a crew on board meant that targeting selection could quickly be changed as the need arose, and the crew could also be trained to perform maintenance on the system if required. The imaging system would consist of a 72-inch diameter primary mirror. The total length of the spacecraft would be 72 feet. Even at this stage, the program faced criticism, and delays in the schedule began encroaching on the project. It was seen as duplicating NASA's Apollo program. Meanwhile, NASA during this period was also pursuing space station studies, including possible plans that built on technology being developed for the Apollo program. Coordination between NASA and the Department of Defense was proposed to prevent duplication between MOL and NASA's space station plans. There was political pressure to cancel MOL and instead focus funding on NASA's Apollo-derived space station project. Officials later determined that the DoD and NASA would coordinate with each other with the goal of determining if any aspects of NASA's space station plans would achieve the goals being pursued by the MOL program. MOL was allowed to proceed. During this time, from May to September of 1964, studies carried out using a simulator demonstrated that an astronaut could indeed operate the imaging system and successfully photograph acquired targets. Tests were also conducted aboard the Air Force's Zero-G aircraft and underwater to demonstrate the astronaut's ability to perform maintenance on the spacecraft. It was also demonstrated that an astronaut maneuvering unit could be used for spacewalks, and those tests were all successful. A review determined that there were no obstacles to developing a life support system that could operate for the 30 to 45-day missions envisioned for MOL. It was also determined that attitude control of the spacecraft was within existing technology, and that ground control facilities would be suitable at least for the initial missions, although those would have to be improved for more advanced MOL missions. In January of 1965, the Air Force was asked to investigate the possibility of using an Apollo variant instead of the Gemini B. NASA's Gemini program began operational missions in March of that year, and during the Gemini 5 mission in August of that year, military experiments were conducted, including photographing ground targets. In October of 1965, Douglas Aircraft and General Electric were awarded the contract. The spacesuits designed for MOL crews were more flexible than those used by NASA astronauts due to the limited space aboard the spacecraft. The mission profile would entail the crew being launched aboard a Gemini B along with the MOL module on a Titan III-M launch vehicle. Upon entering orbit, the crew would shut down the capsule and use the hatch in the heat shield to crawl through a tunnel leading to the lab. Tracking telescopes would be used to search for targets for the main camera to photograph. Targets would be pre-programmed, and the camera could photograph automatically, although the astronauts could prioritize targets, enabling them to conserve film. This was seen as more effective than satellites. The main camera was to have a field of view 9,000 feet across and at maximum magnification 4,200 feet across. At the conclusion of the 30-day mission, the crew would transfer to the Gemini B and separate it from the lab and return to Earth. The MOL module was designed for a single mission only, and its orbit would decay and would burn up in the atmosphere. There were plans for more advanced Block 2 versions of MOL, which would include real-time image transmission and astronomical observations in addition to the reconnaissance mission, and further plans beyond the Block 2 versions of MOL entailed permanent space stations. The planned reconnaissance missions would require launching into a polar orbit. However, launching southward from Florida would be difficult, since launching on such a trajectory would mean overflying land. Instead, Vandenberg Air Force Base in California was chosen. Construction of Space Launch Complex 6 commenced in March of 1966 and was completed in August of 1968. The Air Force coordinated with NASA to acquire spacecraft designed for the Gemini program. In November of 1965, NASA handed over examples of Gemini hardware to the Air Force, including a mock-up and the previously flown Gemini 2 capsule. During this period, and continuing into 1966, the superiority of a crewed versus uncrewed system was being investigated, with the DoD ultimately deciding to proceed with a crewed MOL, although the program was running into budget cuts, schedule slippage, and delays in developing hardware. In November of 1966, an uncrewed test flight was carried out using a modified Gemini capsule and an MOL mock-up, which was launched on a Titan III C rocket. The Gemini separated and flew on a suborbital path while the MOL mock-up continued into orbit. The hatch and the heat shield of the Gemini was successfully tested during re-entry, and the capsule was recovered near Ascension Island in the South Atlantic by the USS La Salle after a 33-minute flight. The MOL mock-up went into an orbit with an apogee of 165 miles, a perigee of 161 miles, and an inclination of 32.8 degrees, and it remained in orbit until its orbit decayed in January of 1967. The first uncrewed launch of a complete MOL was scheduled for April of 1969, and the first crewed mission was planned for December of that year. Although there were concerns over how MOL would be perceived by the international community, U.S. officials insisted that its use would be for peaceful purposes. Public discussion was limited due to the partial secrecy surrounding it. Some details were made public, although the actual intelligence gathering mission was kept secret. The program was facing budget problems even from its beginning, and rising costs led to budget cuts, and there were also delays in development of key hardware. It competed for funding, with the budget being affected by the rising cost of the Vietnam War, leading to further schedule delays. Also, the need for MOL versus already successful satellites were questioned. Newer satellites in development were seen as having similar capabilities to MOL. By 1967, the program was encountering further budget problems. The DoD was increasing spending on the Vietnam War, along with other programs competing for funding, and these funding problems pushed back the first crewed mission to August of 1971. By March of 1968, there was opposition from the CIA on the grounds that uncrewed reconnaissance satellite technology was advanced enough to negate the need for a crewed system like the MOL. There was also increasing political pressure to cut the budget further. The first mission would be delayed from 1969 to August of 1971, and then moved back to December of 1971. The need for a crew was debated as automated reconnaissance satellite technology was being developed. Crewed spacecraft allowed for flexibility in photographing targets, and some argued that automated reconnaissance technology wouldn't advance enough to be comparable to what could be achieved using a crewed spacecraft. By 1969, the program was behind schedule and over budget, and no hardware had been flown except for the initial test flight. Plans for missions were delayed and were planned to start in January of 1972. Meanwhile, technology for uncrewed satellites had advanced enough to render MOL obsolete. Nixon administration officials began reviewing the program. There was further CIA opposition, again citing the advances made in uncrewed reconnaissance satellite technology. There were also further slips in the schedule, with the first crewed mission now scheduled for February of 1972. Along with this, there was further political opposition and pressure to cancel the program. In June of 1969, the program was officially canceled. If it had flown as planned, it would have been the first space station. The total cost of the program was $1.5 billion, equivalent to $15 billion in 2025. Following cancellation of the program, MOL technologies ended up in other programs, such as Skylab, and some of the imaging technology became part of NASA's Earth observation systems. Hardware developed was transferred to the Air Force and to NASA. 7 of the 17 astronauts selected for the program transferred to NASA, and they later flew on space shuttle missions in the 1980s. SLC-6 at Vandenberg was nearly completed and was later modified for space shuttle launches. Space Shuttle Enterprise was used for fit checks in 1985. However, the Challenger disaster in January of 1986 led to the Air Force canceling plans for polar orbiting satellites on the shuttle. SLC-6 was mothballed until the 1990s and was modified to launch other rockets, including the Delta IV and Delta IV Heavy. 6 of the 72-inch mirrors were given to the Smithsonian Astrophysical Observatory for its multiple mirror telescope, which was built on Mount Hopkins in Arizona. While it was known to the public, most aspects of the program were classified by the NRO until 2015. The MOL project was very ambitious considering the technological limitations of the time of its inception, and might very well have come to fruition if, ironically, technology hadn't advanced as rapidly as it did, with uncrewed satellites ultimately superseding the need for a crewed reconnaissance spacecraft. Despite the program ending without any missions flown, much of what was planned for the MOL program was ultimately achieved by both NASA and by the military in terms of Earth imaging from space in the years following the program's cancellation. Thanks for watching. If you enjoy this video, please like and subscribe and check out the other videos on this channel. And remember, when the future was cool.